Hello everyone, this is Dikshita Kakarla. Today we are going to see few topics in data mining and data warehouse. Data mining and data warehouse are two interconnected technologies that are used to extract valuable insights from large volumes of data. Next, let's see what is data mining. Data mining, it is a process of discovering patterns, trends and relationships in large data sets. It involves the use of statistical algorithms, machine learning techniques, and other analytical tools to identify hidden patterns and correlations in data that can be used to make informed business decisions. Data mining is used in variety of fields including finance, healthcare, retail, and marketing. Data mining means it is a process of sorting through large data sets to identify patterns and relationships. It helps to solve business problems through data analysis. Data mining is a technique that enables the enterprises to predict the future trends and make more informed business decisions. Few important features of data mining are it utilizes the automated discovery of patterns, it predicts the expected result, it focuses on large data sets and databases, it creates actionable information. Now let's see few advantages of data mining. First is market analysis. With the help of data mining, we can predict the market that helps the business to make the proper decision. For example, it can predict who is the keen to purchase and what type of products one can purchase. The next one is financial market analysis. There are many different types of techniques that are widely used to help the model financial market. The next one is trend analysis. One can analyze the current existing trend in the market that will work as a strategic benefit because it helps in reduction and manufacturing process accordingly to the public demand. Fraud detection. Data mining methods can help to find with cell phones, insurance claims, credit and debit card purchases on ongoing fraud. That means it provides proper security. There are 7 steps involved in data mining, namely data integration, data selection, data cleaning, data transformation, data mining, pattern evaluation, knowledge presentation. Firstly, what is data integration? The data miners combine different data from different sources to perform analysis. All the data which is collected is stored into a single data source called target data or target database using some technology. Next one is data selection. In this step, the data which is required to fulfill our research or to fulfill the user's need is selected and proceeded. Next step is data cleaning. The data is imported or collected from different sources, so it may be in different formats. According to our requirement, we need to clean the data and using some data cleaning algorithm. The next step is data transformation. The data which is cleaned is then pre-processed and transformed into next standard format. The next step is data mining. Step we the user will analyze and identify the type of data mining algorithm which is suitable for the current process or current data, and by applying that algorithm we can identify the hidden patterns. Pattern evaluation. The pattern we identified from the data is evaluated to gain the information or knowledge out of it. The last step is knowledge presentation. This is the actual goal of data mining technique, where the knowledge is collected from the data mining process and it will be helpful for taking crucial business decisions for the benefit of the organization. Now let us see about the data warehouse. Data warehouse is the process of collecting and storing large amount of data from the different sources in a centralized repository. It means data warehouse refers to a place where the data can be stored for a useful mining. It is like a quick computer system with a large amount of data storage. Data from the various organization systems are copied into the warehouse and are fetched when it is required. Data warehouses are designed to support the business intelligence activities such as data analysis, reporting, and decision making. They are optimized for complex queries, high speed data retrieval, allowing organizations to quickly access and analyze the large amount of data. Now let us see few important features of data warehouse. Firstly, subject oriented. The data warehouse itself is a subject oriented because it provides useful data about the subject instead of giving about whole company's operations. The subject can be customers, marketing, suppliers, product, promotion, or any other, etc. The data warehouse usually focuses on modeling and analysis of the data that helps the business organization to make the right decisions at the right time. Time variant. The different data present in the data warehouse provides information for a specific time period. Integrated. The data warehouse is built by joining different data from different sources as a show, such as social databases, level documents, etc. Non-volatile. It means the once the data is entered into the warehouse, it cannot be changed or modified. Data warehouse architecture. The architecture of the data warehouse is divided into sources, warehouse, and end users. Here in sources, we have operational system and flat files. Operational system means it is a method used in data warehousing to refer the system that is used to process the day by day transactions of the organization. Flat file system. Here in flat file system is a system of files which transactional data where the transactional data is stored, and every file must have a unique name and it should not be repeated. Next is data warehouse. Warehouse contains metadata, summary data, and raw data. Metadata means a set of data that gives the information about the another data is called the metadata. Next, end users. The principle or the purpose of the data warehouse is to provide the information to the business managers about the strategic decision making. That means to help the business managers to make the good decisions in the market and plan accordingly. The examples for end users are application development tools, executive information system tools, online analytical processing tools, data mining tools, etc. Overall, data mining and data warehouse are closely related because data mining requires large volume of high quality data which are typically stored in data warehouse. It means data mining requires huge amount of data which is actually stored in the data warehouses. Data mining is used to extract insights from the data warehouses, and the results of data mining are often stored in the data warehouse for the future use. In summary, data mining and data warehousing both are essential technologies for the organization that want to extract insights for the large volumes of data. They are used in decision making and help the business manager to improve their business in the market, and also help in gaining the profits in the competitive market. The next topic is multidimensional model. The multidimensional model is a critical component of both data mining and data warehousing. In data warehousing, the multidimensional model is used to organize and store the volumes of data, making it easier to access and analyze the data. In data mining, the multi-dimensional model provides a framework for analyzing for multiple perspectives, enabling the users to uncover hidden patterns and relationships in the data. By creating a multi-dimensional view of data in the data mining, users can explore the relationship between the dimensions and the measures. For example, a user might use a multi-dimensional model to analyze the customer behavior by looking at the relationship between the product purchases, demographics, and the customer satisfaction, which is given in the reviews. In data warehousing, the model contains dimensions, measures, where each dimension represents the specific attribute of the data and each measure represent a value. By organizing the data, users can quickly analyze or get the data from different perspectives, gain insights, patterns, relationships, and might not be apparent in flat data structure. For example, data warehouse might combine customer information from organization, website, and comment cards. Working of multidimensional model. This includes 6 stages of multidimensional model, and they are: as first stage 1 is assembling the data from the client. In this stage, a multidimensional model collects the correct data from the client in detail. Stage 2, grouping different segments of the system. In this stage, the multidimensional model recognizes and classifies the data according to the sections they belong to, and it builds a problem free to apply in step by step. That means it separates the data according to the place they belong to. Next stage is noticing the different proportions. In this stage, the basics on which the design of the system is based, the main factors are recognized according to the user point of view. The factors are also known as dimensions. Stage 4, preparing the actual time factors and their respective qualities. In this stage, the factors which are recognized in the previous steps are used in identifying the related quantities. These are known as attributes in the database. Stage 5, finding the actuality of factors which are listed previously for their qualities. In this stage, the multidimensional model separates and differentiates the actuality of the factors which are collected. These actually play a significant role in the arrangement of multidimensional data model. Sixth stage, building the schema to the place of data with respect to the information collected from the above steps. In this stage, on the basis of the data which are collected in the previous steps, the schema is built. Here is the example for multidimensional data representation. We have items, locations, and time. In items, we have milk, egg, and bread, and there are different time and different locations. These are the different categories which belong to a single frame. Here it is an 2D representation. The factory sales for the Bangalore are the time dimensions which are organized into quarters, and the dimension of items are sorted according to the kind of the item which is sold. The next topic is difference between OLAP and OLTP. OLAP stands for Online Analytical Processing. OLTP stands for Online Transaction Processing. OLAP consists the type of software tools that are required for analytical analysis and business decisions. And OLTP provides transaction-oriented applications. Now let us see the difference between OLAP and OLTP. According to application characteristics, OLTP ordinary management and production, OLAP analysis decision making support. Users in OLAP information system experts, OLTP decision makers. Data scheme in OLTP it is entity or relationship, OLAP star snowflake constellation. Normalization in OLTP it is frequent, in OLAP it is scarce. Data in OLTP is up to date and raw data. In OLAP it is achieved and aggregated. Updating in OLTP it is immediate and real time. It is delay or postpone. Queries are simple, regular, and predefined, predictable in OLTP, whereas in OLAP they are complex, they are difficult to predict, and they are irregular. Query language in OLTP is SQL, QBE, QUEL. Whereas in OLTP it is MDX, XQuery, XMLA. Analysis access in OLTP it is unidirectional or bidirectional, whereas in OLAP it is multidimensional or multi-axis. Operations in OLTP are modification, up-to-date, cancellation, or insertion, whereas in OLAP lecture, cross-analysis, refreshment. Data size in OLTP are in megabytes or gigabytes, whereas in OLAP terabytes, petabytes, zettabytes. Thank you.